So going into the discussion on, okay, so going again, now going into the discussion on Ohm's law. This law was formulated by George Simon Ohm. No? That's the English way of pronouncing. Others would pronounce it as Georg Simon Ohm because he's a German. Now, the way we write Ohm's law is either in any of these three expressions. V is equals to I times R, or I is equals to V over R, or another way of writing it is resistance is equals to voltage over current. Now again, voltage or electric potential is the one that push the charge in a circuit. And the one that goes around the circuit is known as current. And therefore, now if we divide the voltage by the current, now according to this third expression here, we can get the value resistance, now which we can label as ohm. Now, another way of writing our notations here, no? So sometimes if we are dealing with volts, no? We sometimes write volts with a symbol V, and then ampere can be written with a symbol letter A. Usually we use capital letter, and then for ohm, we use the Greek symbol omega. And I don't have the symbol. Let me just draw the symbol for you. So usually this is how it would probably appear. So that's how the omega symbol would probably look like, but something similar to that. Now, if we are given, for example, a circuit, no? So a circuit we will always have a schematic diagram. And in this circuit again, we will have wirings. And then part of our circuit will now need, no, that we will add a device that we will call resistor. So the resistor is drawn, no, in schematic symbol as a zigzag line. Something like this. No? So this is a symbol for a resistor. Maybe now that's one too many, no, but somehow that's one good way of representing. And then we will now complete our circuit by drawing another line here. And then this line now will go to our battery. No? So this is what we call a schematic symbol. No? So this figure over here, we call it as resistor. And resistor or resistances are indicated by some kind of a symbol R. Now, a resistor, guys, is very similar to an appliance, no, like a refrigerator, a flat iron. No, these are pictures of what we call, no, resistor. No, now when we have a wiring here, no, and so we have a wiring there, we connect it to a resistor. Now we will also attach to this, no, a battery, no, in order for current to flow in our circuit. No, so our battery is drawn with some long and short lines. So again, the long line is an indication of a positive side, and a shorter line is an indication of a negative side. No? And we have the last one. No? So this is the negative end of the battery below. No? So we believe that this is the positive side, and this is the negative side. No? Now we could have here a battery that is somewhere around 12 volts. No? So maybe we have a 12-volt battery. So we can call it with letter V, of course. Pwede ito na siya butangan sang letter V. V for voltage, no? So we are supplying our circuit with 12 volts, no, of battery, no? So positive side, negative side, and here is your resistor. Supposing our resistor here, no, will have a value See, the resistor is around 10 ohms. No? And 10 ohms may also be written as like this. And then you follow it through with an omega symbol. Something like that. No? So we have, again, no? An omega symbol, so it's quite difficult to draw it. Oh, sorry. So let's just use the word ohm instead. So we have a 10 ohm resistor. We have a 12 volt no, battery. And once we connect the circuit here, no, usually some circuits will have some kind of a switch. No? Now, sometimes the switch can be drawn in this way. So you have here a kind of an opening. No? If you represent that as a switch, then maybe we will create a kind of a line here. No? So we could create some kind of a line that we can turn on and off. No? We draw a curved line here. This is a way of turning it on and off, a symbol for a switch. So usually when the switch is off, we call it as an open circuit. Open circuit means we switch off the circuit, the switch, no. So if it's a light bulb, it will not light up, no. And when we turn it on, no, we call it as a closed circuit. So this is when we turn on, no, our switch, no. So therefore, when we turn on our switch, when we close the circuit, we will see that there would be some kind of what will now travel here is your current, no? And by convention, current is always traveling from positive to the negative. It will now enter your resistor, no? So this is now our representation of our current I. Now, ang question, how much will be the value of this current, no? Okay, so the current, again, no? The current flow is positive, no, to negative, no. This is what they call as conventional current flow. Now, ang ato niya nga, the other type of charge that moves, no, if we will allow another charge to move here, if you will have another charge here, no, so the charge nga electron, if we will have an electron, the electron travels in the opposite direction. It is moving now from negative to positive siya yan, no? Ang electron. So yeah, no, somehow there's a distinct difference between an electron flow, no? So this is how the electrons probably travel, no? So an electron travels, no, from negative to positive. Now, if we will basically use, no, our Ohm's law principle, then we can easily find I, no? So again, no, out of these three different equations here, we can simply use number 2, no, to find the value of the current I, no? But of course, no, we don't use the direction of the current in our analysis. We always use the direction of our current, this red line, no? So if we will now solve, no, so if we will try to calculate, so calculating, so our solution now, if we will solve for I, no, so let's change the color there. Probably let's use blue. So solution I is equal to, no, V divide by R. No? So we will therefore divide 12 volts. We will divide it by 10. We will have there now 10 ohms. Okay. So therefore, now, if we divide 12, 12 volts, no? So let's say we'll just have it below, no? So 12 volts divided by 10 ohms, then current, no, will be equivalent to 1.2. So we'll have here 1.2 amperes, no? Or maybe, no, let's just write it as 1.2A, no? Okay, so that's our current, no, that will be traveling in our circuit. So again, this is a simple expression that denotes, no, the relationship of the current, the voltage, and the resistor. Now, you notice if you're going to increase the resistor, guys, no, if you'll make this 100 ohms, no, what will happen to the current, no, if you will increase the value of the resistor, no? So if we change the resistor, no, if we change our resistor now and use a resistor equals to 100 ohms, and supposing we will use the same voltage, 12 volts, no, we will notice that the current now, I, will be drastically affected, no? So how much will be our current now? So again, that will be 12 volts divided by 100 ohms. And therefore, now that will now reduce the current, no, to a small value. No? So may mo, so 0.12 ampere. No? So nagamay siya. No? So again, no, resistance and current have a reverse or an inverse relationship. So increasing resistance, again, no, directly affects the value of our current.